Hey guys, what's that? Oh, you're right. No big red beard. But you know what? I do have some red hair for a limited time only. Just kidding. Well, of course I'm not Mr. Nazelli, whom I call Mr. Nazelstifer. That's my homie right there. And a little known fact is that actually when I was in college, he was my math teacher for several classes actually. But my name is Kimberly Rice Cofield, and you can call me Mrs. Cofield. And so I'm going to be riding along on this track with you guys until the duration of the operation of the real numbers ends. I look forward to working with you all this summer. Today, lesson number 5 is entitled Addition. Now, I know that you guys have been reviewing heavily, and let's talk about algebra. If you recall, algebra is the study of the operations on the real numbers. Now, I know that you've reviewed what the real numbers are, what they look like, and where they live, and the numbers that's in between, such as decimals and fractions, rational numbers, irrational numbers, all these types of things. But now, we finally get to talk about the operations on the real numbers. Now, there's something really important I need to tell you about the operations. There's a myth. In fact, the fact is, they've been fooling you for years. I mean, there's this big myth that exists, actually, that there are 4 operations on the real numbers. They're trying to tell us that it's addition and subtraction, multiplication, and division. But guess what? That is not the fact. We're going to blow that myth out of the water, and I'm going to tell you guys, there are only 2 operations. Can you guess what they are? What's that? I think someone got it. They are addition and multiplication. Here's why. Because subtraction is actually just addition of the opposite, and division is multiplying by reciprocals. But we'll talk about that later. So let's get into the basics. Here's where we would like to start. Now here's a fact, and I want you to write this down in your notes. The number 0 is the additive identity of the real numbers. So what I mean by that is that a plus 0 equals a, and a can represent any real number. So, for example, let's say I have the number 14. 14 plus 0 is just 14. Simple, right? And then if we had negative 2/3 plus 0, that's equal to negative 2/3. So just add 0 to it and you basically get that same number. Okay? So, continuing on. So here's another fact. Every real number has an additive inverse, also known as an opposite. So the sum of any number and its opposite is 0. Here's why. The opposite of 7 is negative 7. And when you add those two together, you get 0. So 7 plus negative 7, that's just 0. Easy, right? So the opposite of 2/5 is negative 2/5. Since 2/5 plus negative 2/5, in other words, its opposite is equal to 0. So simple. Now, here's one more fact that you need to know. Addition is commutative. What that means is that for all real numbers a and b, a plus b is just equal to b plus a. So all we did was switch the numbers around. So, for example, 2 plus 3 is just 3 plus 2. Whoop-de-doo. Now, we're going to get into adding with integers. Now, recall this from your class before that we can add using n's and p's. And here's what that would look like. For example, 5 plus negative 3. Now remember that p represents the positive numbers and n represents negative numbers. So if we were to write them out like this, we have 5 p's and 3 n's. But here's what you need to know. There's been a battle going on between the p's and the n's forever. Like, they just don't get along. They don't like each other. So whenever they come together, they clash, and then they take each other out. So if that was the case, since we have 3 of those red guys, boom, 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 and they took out 3 of those blue guys, what do we have left? We have just 2 left. That's 2 of the positives. So they were the victorious ones, the positives. That's so simple, right? I mean, you could do this in your sleep. Let's try a bigger number. Now this time I want you to give it a try. Let's say we have a negative 28 and we're adding 21. Now we don't necessarily want to use n's and p's here. Like in a case like this, Can't you just see it? There's a battle going on. Boom, boom, boom. You get it? They're fighting, and you can just easily see that you're going to get a -7. But okay, maybe you don't see it as quickly as I did. But if you don't see it that quickly, here's what you can do. Take out a scrap sheet of paper, and then I want you to scribble down on the side. And all you got to do is ask 2 questions. What do you have more of? So we look at it and we see there's a -28 and then a positive 21. We have more negatives. So we know that the answer is going to be negative because we have more of the negatives. Then the next question is how many more? Then you can just do like simple take away 28, take away 21, and that gives us 7. So that's why we know it's a -7. Simple mathematics. So moving forward, now we can get really crazy with these N's and P's and things like that. But let's say in a case like this, you had -2 plus -6. Now, what do you notice about both of these numbers? Well, they're both negative. So we have 2 N's and then we have 6 more N's. You put the N's together and what do you get? -8. Now, we're going to take it to another level right here, okay? And this is one of my favorite parts. This is called the main principle of addition. Like, it's like my all-time favorite. I made a song about it and everything, and the kids love it. So what the main principle of addition says is, the only things that you can ever add are the same things. And when you add the same things, you get the same things. My little rap went a little bit like this. The only things you can add are the same things, and when you add the same things, you get the same things. Whoop! Now I'm expecting you to learn that by the end of this class, okay? Practice that. So let's do some addition considering those facts that the only things you can add are the same things. So the instructions say to add if possible, and if it's not possible, write NP. So first example, 3 dogs plus 2 dogs. So what are the things that we're adding? Because remember, you have to add the same things to get the same thing. We got dogs plus dogs. So guess what we're going to get? More dogs. How many dogs? 5 dogs. Boom. Big picture, right? So what about in this case right here? We have 3 dogs plus 2 chairs. Look at those things right there. Can you add dogs to chairs? What? Of course not. No. The only things you can add are the same things. If you add dogs and dogs, you're not going to get giraffes. You're going to get more dogs, but you cannot, and I mean you cannot add dogs and chairs. So that is not possible. Let's try another example. What about if we have 2 7s plus 3 7s? Are they the same thing? Yeah, they're 7s. So add them together, we get 5 7s. How about if we have 10 13ths plus 7 13ths? Well, the thing is, 13ths, we're looking at that denominator right there, 13ths. When you add these 13ths together, what do you get? More 13ths, 17 13ths. Easy. Now, lastly, we have 2 7s plus 3 5ths. Think about it. 7s, 5ths. Are they the same thing? Nah. So you can't add them because you have to only add the same things. That's the fact. Okay? So, remember that algebra, we can take this thing to a way different level. I'm saying like high school algebra, we can start tapping into it right now. But just remember that rule in your head. The only things you can add are the same things. So let's say we had 4x squared y's and we added 6x squared y's. Well, our things are x squared y's. If you add 4 plus 6, then you're going to get 10 of those. What are those? X squared y's. You get the same things. And then here we have 8x plus 6y. Can you add an x and a y? Not today. The answer is no. Okay? So that's not possible. You have to have the same things. You got me now? So let's review. There are only 2 operations, and that's the 2 that I talked about. Addition and multiplication. Not the 4 like they've told you before. That's not true. And the fact, the number 0 is the additive identity of all the real numbers. And every real number has an additive inverse, or an opposite. And the main principle of addition? Let's see if you learned the rap yet. The only things you can add are the same things, and when you add the same things, you get the same things. I'll give you some more time to practice that if you didn't get it today, okay? But remember that it's a fun fact. All right. Well, I hope you enjoyed today's lesson number 5 in addition, and I look forward to working with you tomorrow. Have a wonderful day and enjoy your assignment.